Good morning, everyone. Okay, we should be live. Yeah, so it's more of the same. More of the same. Yeah. Right. Okay. Usually I'd wait about I'm gonna wait I'll wait 5 minutes or something. Just take a look at the code. Yeah, like holy crap, look how long this is. This can be replaced with an FMA. It's much quicker. So all of that, fmol FMA 1, look, it's much shorter. So much shorter. This is all branchless. It's all branchless, except when you get to here. Except when you get to here. But this is a branch that's rarely taken. Very rarely taken. Maybe I can do something with branch hinting. Wait, where were some of the features? There is branch hinting. Branch hinting is like supported everywhere, which is interesting. This is very quick to be supported. What you can do is there's a branch hint section in WebAssembly. It's just like a place where you can put bytes. Those are just sections, right? A custom section. And then in here, you can basically like hint code paths. So like you could go to this index here, right? And write that this is very unlikely, for example. Yeah, it's just super simple. Yeah, brif and if instructions, at least one branch hint notation must be given per instruction. Yeah. Yeah. So that's it. It would be nice to have. So maybe look into branch hinting for branch hinting is interesting. Yeah, I have unlikely here, but it's not letting the JIT know. Which it should. It'd be nice if it did. Okay. I think it's time to start. So what did we do last time? This is last time. Actually, just go to the website. What did we do last time? Alright, 3 days ago. So we looked into the issues with the FMA, fuse multiply add. Like, why is it not compiling correctly? Well, why is it not running correctly? I fixed it. So the implementation of for example, if you look here, right, fmul1, this is multiplication, but rounding down to the nearest floating point number, right? This is long, slow code. You can actually look at what the code is, right? You go to stub fmul1. This is what this is what my build script produces and the JIT uses to insert. This is it. These are the opcodes. It's a lot of code. It's all branchless except for this part, but this part is a very unlikely branch. Absolutely unlikely. This handles infinities. So this is all branchless code, but we want to make it shorter. So you can basically re-implement all this fmul stuff using FMA. And that's what we do here, right? So it's just fmul FMA1, right? It's the same thing. You perform the multiplication, you get the residue, and then it's just the same next after function with the res, right? So there's two implementations of mul residue, right? This is the original one. It's just like mul residue normally, right? And then there is mul residue using FMA, and it's a lot shorter, so much shorter. So if you look, right, this is mul residue. It's a lot of code. It's branchless at least. But you can re-implement all of this using this WASM F64 times 2 relaxed madd. So if you use multiply add, right, it's very simple. So if you want to get the error in a floating point calculation, right, well, we want to find, well, what's the error really? X. So X is equal to, where's the like here, right? O is like our rounding function. We want the rounding in multiplication, right? So it's just like A times B is in C, right? Well, to get the error, so this is epsilon, right? If we want to get the error, it's the rounded part minus the actual part, right? But when you compute this, right, a rounding happens here, a rounding happens here, and a rounding happens here, right? What you're actually computing is this, right? Round. So this is stored separately. This is like above. This is like this, right? So it's more so like this, right? You're basically it's more so like this minus C. Okay, yeah. So to find the epsilon error, right? It's just like calculate A times B minus the rounded part of A times B, right? It's the just calculate A times B minus the rounded part, right? So you want a rounding at the end. You want to compute this with infinite precision. A times B minus C with infinite precision. But if you write it out naively, this is what it looks like, right? This is just like this minus this. That's just 0. That's not an actual implementation, right? So this gets rounded, that gets rounded. So it's a double round. What we don't want is a double round, right? We want to compute this. Right, we want to compute this with a single round, right? This is called fuse multiply add. So fuse multiply add is basically what it is. Like it fuses the multiply and the add, right? Which is what we're really doing is this, right? It fuses the multiply and the add, and it does it in one rounding. So to get the epsilon error, that's it. That's just like super easy. So I go over this in my talk. If you want to watch it, it's on YouTube. It's on YouTube, right? If you're watching the vlog, if you not vlog, a VOD, right? If you're watching the VOD, you'll probably find it as well. FMA. Yeah, semifloat FMA. So if you're looking at the VOD, like you'll be able to find this on my YouTube channel. But I explain the entirety of random RXJS and the semifloat part, things like that, right? And we get to this deriving thing, right? So is there a way to do A times B minus C in one rounding, right? Is there a way to do this? Well, you use FMA. That's why FMA is so good, because it does this in one rounding. Yeah, so I just explained, like, how does, like, semifloat work? These things like error-free transforms, like, for example, getting the epsilon error, like some residue, mul residue. So for some residue, right? How do you know if you round it down? If you can get the error in rounding, it's just like if the error in rounding is less than 0, right, that means you rounded up, which means you want to round down, right? Else, it's exact or you already rounded down. This is for fadd1, so it's like, okay, you always want to round down. This is the implementation of that. You can use that by getting this epsilon error. That's it, right? Yeah. So I went over this in my talk. If you want to look at it, it's nice. I'm always going to be shilling it. I'll go on YouTube and just like show it. There you go. Here's the one. I explain like a decent amount. I explain like a decent amount of stuff. So
Hey.
yeah, it's like 40 minutes.
So I wanted to try and beat
Is RandomX, semifloat implementation, you know,
WebAssembly SIMD.
yeah, could be good if you're interested. So what are we doing? We're continuing this project. This project's like 2 years old now, which is crazy. So we're continuing this project, and yeah. So let's see. So yeah. So what we did last time was fixing the FMA. So that works. That provided a substantial performance increase, like a substantial, like a decent amount. In here, right? If we can go look at the performance increase. I think like I write about it. Yeah. So the performance increase is like we get like around 4 to 5 hashes a second increase, which is great. Like that's amazing. It's just really good. That's like really hard to do. Getting like 5 hash like to get like squeezing out extra hashes is very hard. So I was like lucky I got to do this. So an increase of 5 hashes a second. This gives you like 50, like 40 in the threaded version, right? It's like multiplied over the threads. That's nice. So that's good. That's good. So FMA, that's out. So that works perfectly fine. So the goal right now. So that's what we did last time. The goal is really improvements to the code generator. There's not really much I can add. Like for the code generator, it's just like basic fixes, pre-computing addresses, fixing the code gen, implementing batching API. That's like changes to the cryptography. There's like a decent amount of stuff to do there. There's like lots of little fixes, but also if I want to test out a completely new way of compiling the code, I'd need to basically like rewrite the entire thing. So I'm just evaluating different kinds of ways to do code generation. Like I'm interested in like a very long instruction word kind of code generator, because the instructions have a probability attached to them. So it's highly likely that you get certain instructions that are generated closely to each other. Then you can use like a very long instruction word kind of thing to merge them, like fuse them together, fuse the instructions together. And I was thinking like maybe that would be good, but I'm just thinking about it at the moment. So the code generator generally it'll just be a hard thing to think about. These things are little tiny fixes. I can do them. It'll be nice to do this on stream. It'll be nice. Yeah, and the batching API, that's just cryptography stuff. I just gotta follow the RandomX repo. And then here, implementation of a proof of concept web miner. So we're gonna do web mining. I want to implement a proof of concept web miner, because at the moment, right, the only benchmarks I have is this, right? I have RXJS. This is like the benchmark. All it does is it initializes the cache, creates the VM, and just loops and gets the average hash rate. Like this average hash rate is like, this is like fake. It's not like if you do this in a loop and calculating the hashes, that's like not a benchmark. You're not getting the maximum amount of hashes that you could get, right? This is like the overhead is in JavaScript, right? You're leaving and entering JavaScript repeatedly. It's not what you want. Like, and even here in the threaded, right? The threaded version is literally I just copy this code and paste it on every thread. I just paste it on every thread. that's also like not good. That's also like slow. Um, yeah, you're not reaching your potential there, and these aren't benchmarks. These are fake benchmarks. Like, so I need to implement an actual web miner, and like an actual web miner. So, looking at where some of the overhead is, for example, just where some of it is. So you're looping over and over and over again, and you're calling calculate hex hash, right? So I'll show you where some of the overhead is in calculate hex hash. It's just a function. It calls hash and then reads it from the WebAssembly module stuff. Reads it from the like existing buffer. So it calls hash. So how it works is you first you this is the hash seed. This is the like data. So you basically call the initialization. We can actually like show side by side. Okay, so how you actually hash something. The like the like JavaScript and the WebAssembly, they have to like do a little dance to like install the seed, and then what's it called? Relieve control, like a rescind control or something, give control back to JavaScript so that it can JIT the code for WebAssembly. So how it works is, okay, so first you call I. This basically initializes everything, right? I do like when you generate the hash, it puts it in hex or in using bytes. It's nice to like calculate the hex stuff in here. It's like quicker. So when you call I, you're passing is it hex or not. It's just a global variable. The program count, it sets the program count. This is like an integer value that decrements down. Because we have to execute 8 programs in a chain. 8 programs in a chain. So you call I. This is a Blake2B init key. So it just initializes the key. Yeah, it just initializes it. So this is the like I think, where is it key? Yeah, I think so what you do is the initial seed h is just like the data. First you hash that data with Blake2B and then you run the VM. So what this does is basically it just initializes Blake2B. And then repeatedly you just call h over and over and over again. So in the most likely case, the scratch size is going to be huge, right? Um, I think yeah, it's like 16 kilobytes, right? So if your data fits in 16 kilobytes, which it probably does, right? You just set the scratch pad, like, or not the scratch pad. You just set the memory buffer. I think this is like, yeah, it returns the JIT buffer. This is basically like the working memory. So yeah, after you call I, it returns the JIT buffer, the lowercase I up here, right? Lowercase I, scratch pointer, scratch size. This is just scratch. Yeah, so if it's less than 16 kilobytes, it sets the starting point of the scratch buffer, the scratch buffer, so the JIT buffer, with it, and it calls h with the length. So when you call h, it's just like running Blake2B update on the data. So you repeatedly call h, just hashing the initial h here, the initial hash. You're just calling it over and over again. And when that's done, when you've installed the seed, you just call R in a loop. So what R does is it iterates the virtual machine. So this is kind of like a coroutine kind of thing. It's not, yeah, it's kind of like a coroutine kind of thing. So you repeatedly call R. So this is the first iteration if program count equals random x program count. It does the finalize, so it actually gets the seed s from this is the seed state. So yeah, s now contains the seed. So you modify it, scratch by initialization, you initialize the virtual machine and everything. You go down, you initialize the VM registers, set the registers to 0, generate a program the VM, and then you JIT the VM. So after you call JIT VM, it basically puts into the JIT buffer the WebAssembly code. Just like installs, it just writes the WebAssembly code to the JIT buffer, which is the beginning of the scratch here. So and then it returns the size, returns the code size. So you're repeatedly calling R in a loop. So if the code size equals 0, I mean, we're done, right? Else, you take that JIT size and the scratch, and you basically compile a module, and then you compile an instance. You're passing the exports, and then you just call D. So what the JIT will do is it'll just generate a WebAssembly module with JIT VM. It'll put it into Scratch. After you return from R, it is the JavaScript. So you're giving control back to JavaScript. JavaScript will JIT the module, and then call the code. And then you just keep doing it again and again and again and again. So this, what's it called? Relieving control back to JavaScript and then coming back into WebAssembly. Like, you need to do this. Like, you need to come back into JavaScript to actually create the WebAssembly module. You need to do this. So this is just what it does. And when it's done, for example here, right, when program count goes to 0, it's the ends. So it's the final VM iteration. After the VM's done, it's just hashing the scratchpad. You overwrite like 64 bytes of the register file. And then, yeah, if it's hex, you return it as hex. Else, you just do like 2b, the JIT buffer. So, yeah, so what's left is, at the very end, the initial 64 bytes, or I think, yeah, the initial, the initial 32 bytes or 64 bytes at the beginning of the scratchpad, at the beginning of the JIT buffer. The JIT buffer and Scratch are the same thing. It contains the hash or the hex version of the hash. So yeah, this is like so the way hashing works is it's just like a kind of like a coroutine thing where like you call out to WebAssembly JITs the code, you come back into JavaScript, you compile the JIT code, you run the JIT code, and then you go back to WebAssembly. It's just like in a loop. Right. So you basically, I think like the goal is you want to minimize the amount of time that you spend inside JavaScript. Like, you just want to minimize it. You don't want to be in JavaScript like at all. This is like unoptimal. I mean, it's great for like a super simple library that just needs to call it. But what you want to do is you want to pack in as much stuff as you can in R, as much stuff as you can in the VM iteration, right? And I try to do that. So this is kind of like a state machine. I just try and pack in as much as I can here. So you basically want to pack in more, and especially for a miner, what you want to do is you don't want to be calling a hash in a loop in JavaScript. You want this to maintain the mining state itself. You want it to just repeatedly. You basically want to just like do while one with this over and over and over again, and like you're never calling hash, you're never installing seeds or anything. R does the seed installation and things like that. So I have like a proof of concept already. So I wrote this like a year ago. I wrote this like ages ago. If you can, I think it's here, right? Yeah, VM miner. So vm.c. So it's more of the same. It's basically like R here. So R is the, like, you iterate the thing. Yeah, so what it does is, so you use B to initialize the new blob. This is like the block. This is the block of mining. The thing is like blockchain mining, Monero. I'm not like, I wrote this code a long time ago. I'm not familiar at all with how mining works. I know that you take the block. The block is a piece of just binary bytes, right? What you want to do is you want to put a nonce at the end. A nonce is a 4-byte integer. And that nonce, you just want to keep incrementing over and over and over again, hashing the resulting thing. And you basically, what you want to do is you want to, after you hash the blockchain data with the nonce, it'll just be random, the hash will be random, but you just want to get the hash that has a certain amount of leading zeros in the beginning. And then if that amount of leading zeros is below some threshold, you mine the block. That's my understanding. So like, let's say you have like, this is your like blockchain data, dot. Then this is the nonce, right? What you want to do is you hash this, and this gives you some hash value, right? You want to keep incrementing the nonce until you end up with some amount of leading zeros in the beginning, right? And the difficulty is like, if the difficulty is like, I don't know, the difficulty is like 2, you're gonna have 2 leading zeros at the front. So basically, you're just repeatedly incrementing the nonce and you're hashing, and you're just trying to get lucky. That's a proof of work, right? That's the proof of work. That's how I understand it. I think it's like mostly true, but the thing is I don't understand the binary format of the thing, of how like the blockchain works and things like that. It's just the binary format. So I just need to like understand it. So I wrote this a while ago. This probably works fine. This is probably like how it works. So yeah. So you repeatedly call R, it iterates the VM hash, it just keeps running, and it does the nonce itself. So it installs the new seed completely on its own. So you don't need to create a new blob. You don't need to like increment the nonce in JavaScript. This increments the nonce in its own. So you staying in C much longer. You're not staying in JavaScript to mine. Yeah. Hello. It's good to see you. I'm going to be asking you JavaScript questions. I think actually you might be able to answer a couple of these. Okay, so yeah, it's time to implement the miner. So this is like the old miner code. The old miner code basically, you called on job. This job was the blob, job ID, target, height, seed hash. This is like the blockchain. After you call on job, it'll pack the job into binary, right? It'll like pack it and then distribute it to miners. And then like for each worker, I guess for each worker, iterate will be called. It'll just repeatedly call R over and over and over again. So each worker gets the nonce to nonce end, this like nonce space to search for. So the main thing will just distribute sections of the nonce space, as they call it, the nonce space, to the workers, and they just like churn on them. Just churn on them. What? The statement? Okay. Interesting. What, the second time? It's funny. Anyway, yeah, so a lot of this code, yeah, so this code like needs to be changed. So far I currently have, this is my like this is like my entry point. So how it works is I kind of want to copy CoinHive. I want to copy CoinHive and the other web miners. So like these web miners, they attach onto a tab, right? So for example, if you go to LH, stream, right? If you open multiple tabs of stream, there should only be one web miner running. So what you can do is you can use a weblock and like broadcast channel to have a worker talk to all the other workers per what's called like an origin, per origin. This is like an origin, right? If you go to like example.com or something, right, and they have a web miner, it'll run a new entire web miner. So like all the things between this stream, lsm.dev/stream, right, all the web miners on there will just talk to each other. They'll just talk to each other. So that's what you use with you use a broadcast channel to talk to all of these things. So we only have one instance of a web miner per origin, per website. So we use a broadcast channel to talk to them, and only one JavaScript context becomes the orchestrator. That's how you use a weblock. Use a weblock. So yeah. Haptic 500 pressure painting 500 bell. No, don't. And haptic sync. Okay. Intertab. Yeah. So I'm gonna ask you about that stuff. So broadcast channel is to talk between the different tabs, and then we use weblock to attempt to become the main orchestrator. So what the main does is gonna have to talk to the main like orchestrator will get the jobs. Like so here, right? I guess like I just like pasted this job in. I think I created this ages ago. I think this is like a fake. There was like a really low difficulty like mining pool that I just like extracted this from. So if you become main, you have the you just have the ability to call out to other. You have the ability to like run jobs. Broadcast channel doesn't work on IE. Are you kidding? Really? Well, but shared worker, right? Shared worker doesn't run anywhere. So I was like, okay, broadcast channel. Shared worker. This doesn't run anywhere. Oh my god, it runs on JavaScript, but not fucking Chrome. It runs on Safari, but not Chrome. Is there an alternative to the broadcast channel? Is there an alternative? Oh, it runs. Wait, hold on. It runs everywhere. What are you talking about? See? Chrome 54. No, it runs everywhere. IE is like dead, so of course it doesn't work on IE. Well, what? Since when? Since forever. Since 2022. So it works. Like, yeah, there's no way it doesn't work. So if you become main, you can spit out jobs. So the stratum like job thing, I'm gonna like deal with that later. Right now, this is just a hard-coded job, which is good. So how it works is the main process is aware of the thing is that the main process can change at any moment. So if you close a tab, someone else will attempt to become main. So when that happens, you basically like the new main has to be aware of all the workers running. So what I'm going to do is I'm going to have the workers send a ping back to main. Yeah, they're going to send a ping back to main. When you become main, I think you'll just like what you'll do is I guess like when you become main, wait until you're aware of all running workers. Wait till you're aware of all running workers. When you also become main, you also yeah, they also like might shared array buffer. Like a shared array buffer. This seems complicated. Local storage. Is that better? Using local storage? Because that's what CoinHive does. CoinHive uses local storage. Broadcast channel, like, is not a thing. Can you store a shared array buffer to local storage? It was like structure clone. So can you okay only no but okay structure clone you no local storage uses the structure clone algorithm though I think like local storage. If you look at local storage, structured clone local storage. Does this only work with stringified values? Oh no, it is stringified values. Why do you need to share the data between tabs first open, keep the data from mining on the new ones? I don't know. I think it's an overcomplication. Like, okay, so my idea at the moment is you have main, and then the main wrangles all of these like workers, like worker. The main wrangles all of these workers right at once. The thing is, what main does, main has to listen for new jobs and manage the cache. There's something called a cache, right? It's the only place getting to abuse each tab gets even more memory allocated to it. The reason why, like, okay, the data needs to be shared between the tabs, right? Because there is something called the cache. So the cache is 256 megabytes of data initialized based on the blockchain. I think in Monero's case, it's like block height modulo 248, right? This gives you a key, and then what you do is randomx creates cache, right? You use randomx create cache. This cache is 256 megabytes. This gets returned as a shared array buffer. This is a shared array buffer. This shared array buffer needs to be shared between all the workers at once. So in main, when it gets a new key, right, it gets a new key based on the block height, you need to initialize, you need to create a new cache, and you also need to create a new JIT instance, right? You also need to create, so really what cache is really, this is the cache, and this is like JIT. This is like a superscalar hash. This is like a program. So it creates these two things. It creates the cache, 256 megabytes of data, and an actual program. And you need to send these. So you need to send these over to the workers. So the cache, right? This cache here. This is a shared array buffer. So all you need to do is share it to the workers, and you don't need to share it again. Shared array buffer, only 256 megabytes of data is shared between all the tabs, right? Just shared array buffer. Superscalar hash program you have to send, but that's fine. So in the begin, like what I'm like, my idea is that this cache, right, is just like floating around. So let's say the cache doesn't exist. Main sends the caches to all of these workers, and they keep a hold of the cache, right? When main leaves and main comes back, they lose the reference to the cache. The reference to the cache is lost. The reference is lost. So they need to basically get the cache back from the workers, which is annoying. So there's two ways to do this. My stupid way, or two, when main dies, tear down the workers, initialize a new cache. Do some page init, request a cache from any other worker. Yeah. That's what I'm thinking about doing. So this one, that way, the way that I explained and like what you're talking about, this is way one. Way two, when main dies, you need to so the way two is like, okay, if main dies, tear down all the workers, initialize a new cache. This is like this could be like the slow thing. This could be slow. Initializing a new cache takes like 2 seconds. It takes 2 seconds. Well, it would result in more computation, of course. Yeah, I mean, this takes 2 seconds, and like it allocates slow. So this way seems the best way. I think so. So when we do it this way, when you become main, the first thing you need to do is you need to figure out like what workers you have. Original broken ash or anything. Yeah, that's it. That's basically what I'm doing. So there's the way it works is like this. So how will I what's the best way to know what workers are running at the moment? You don't really need a main to coordinate. Everything the worker requests the cache from other workers. I need a main. No, I need a main to coordinate because the workers aren't like independent processes. for example, like if I get a new job, I'm basically going to, and I have like 4 workers. I basically distribute the nonce space, right? If I get like 4 workers, I'm gonna distribute it like, I don't know, like two to the like I don't know, like int max divided by 4. Int max divided by 4, uh, like times 2, right? I'm gonna have to distribute it like this, right? In the nonce space. So if I have 4 workers, I give the first one 0 to int max divided by 4, right? 0 to something. I give the next one that thing to the next thing, that thing to the next thing, that thing to the next thing. I give 4 different intervals, right? And they have to search this nonce space. Yeah, they have to search this nonce space. So when they search, it's basically just running through and checking the hashes for all of the nonces, which that needs to be coordinated. They can't work on their own because they don't know what they're searching for. They don't know what they're searching for, right? You only work on one job at a time, so you need to like distribute the work evenly. So that means you need a coordinator, unfortunately. Um, so my question is like, what is the best way to know all the workers that are running? Um, I'm thinking like if so does main do the request? So either main does all the so main does the request, or two, wait wait like 200 milliseconds or something for a ping to be sent back. Like this, right? Wait for a ping to be sent back. Well, actually, you don't need to do that because broadcast channel is bidirectional, and like this way it works fine. Okay. Um. Yeah. Okay. So when you look at types, right? I wrote some types. So there are many different kinds of jobs. There is worker message init. Oh yeah. Okay. Backing erasure buffers allocated ones. This is when a new worker is created. New worker. So yeah, there's new workers are created from nothing, or a worker needs to be reinitialized. Um. Okay. When you have a web worker and they don't send any messages down, will the browser put them into sleep mode or something? Because I heard something about you need to ping ping every like 200 milliseconds, just like ping every second to other workers to keep the worker alive. Is that a thing? But for pinging though, like web worker going to sleep, post message ping. Okay, well, ping pong. Okay, well, they say something about this, but that's like the AI overview. Um, okay, whatever, I don't care. No. Because, for example, CoinHive was pinging. CoinHive pinged. Worker sleeps and waits for user input. Interesting. Oh, well, I mean, that's just how it works. Yeah, I mean, okay. So idle put into sleep mode. So what is inactivity? No messages sent or no CPU being done? Okay. And we also need a worker to kill itself if it hasn't been sent a message from main in a while. So maybe the main should ping or something. Um. So ping. So main needs to ping so the workers don't die. Obviously, when you get a new job, that's like a ping, but that's not really a ping because jobs don't come very often. Okay, so I guess I'll make a what type worker ping. Right, the worker is this is the main. Longer ESW lifetimes. What's this? Extension events? Extensions? Oh, okay. Receiving an event. So it's just receiving an event. So, okay, so ping. This is main to workers. It's main to workers. Ping is just a ping. This is oh. What I want to return is the shared array buffer that it has. So if you're already initialized, give main the cache back. So if you become main, you want to ping. So enter the ping stage. So BC. Is broadcast channel like one to many? Like for example, if you have like if you send out a message, it gets sent to everyone, right? Or is it just like it's not the first one who gets it? That's like a channel. I'll put that's in the broadcast channel. Okay, yeah, so that's right. Okay, so post message any, but I'm really just gonna be sending ping. Worker ping. This is two workers. To main worker. mean it's a structured clone thing. Two. So we need. Yes, you can. I think so. I think you can. Or I think you can do that. Well, no, it's nothing's to do with JSON parsable. No, we've moved past that. You can send like buffers. You can send shared array buffer and it's not cloned. Here, structured clone algorithm. Right, JavaScript types. Since fucking when? Since forever. You can send all of these types as well, like all these like web API types. You can send like typed array. Where is it? Where's like WebAssembly? Module or something. But like I've sent like the WebAssembly stuff. Like you can send array buffer. It's interesting. I don't know if you can send WebAssembly stuff though. I know. You don't see it. I don't see it too. Maybe maybe you can't. No, I think you can. No, I think you can because I do it. In here. Yeah, I do it. So it's self.on. Oh, okay. Self.onMessage randomx create VM. So this is like this runs in the web, but what is put in here is it's not WebAssembly memory. I think it's not WebAssembly memory. It might be. On the single on the server. What does the server do? What does the server do? Okay, index HTML. Here's the yeah, it's jank. I know it's fucking jank. I know. Here, so this initializes the workers. Okay, so it's cache.handle. The handle is what is the handle? vm.ts. The handle. Okay, the handle is these three things, right? Yeah, I know. Well, no, that's navigator. Isn't that how you do it? Navigator hardware concurrency. I don't know. Isn't that how you do it? Anyway, the cache handle gets sent over a thread, and it's these things: memory module, which you can do that. LibreWolf by default spoofs that. Yeah, but whenever I test, I use Chromium. When I test, I use Chromium. That's when I test. Yeah, but look in the README. In the README, right? I like mining using the shitty mining on the server. This is like 240 hashes. What do you mean ill node? No. Who uses Dino? Bun sucks though. Alright, 2 workers. So type. This is a ping. So just gonna ping it. Enter the ping stage and then wait. I'm just gonna wait. bc.onMessage. How do I do this? I make this a promise, right? Because what I want to do is I want to like no, add event listener or on message. I'm gonna do on message here. I don't want to add event listener because I want to overwrite the things. Why? Why? Is it bad? What happens? Doesn't message event any. Why? What happens? It's just jank? Yeah, but the thing is like I only want one. I only want one handler. So await new promise. Let's yeah, I know. I bet ESLint sucks. I bet ESLint does that. I hate ESLint. If I work on a project with ESLint, I literally, like, I just delete the ESLint file in the directory. Okay, so on message, data. Data is the thing. This is the data, right? So let. Oh my god! See, look, I'm using this because I'm so used to lean. This is a from worker. Did I mean to worker? No, I meant from worker. Buddy. Okay, to main worker. Oh, I mean, I should call it from worker. That's nice. That's much better. Worker. From worker. Golang. No, lean has that. Data. Great. So I just wait. So it's just like all the workers let so the first cache that we get back is the so we're gonna reuse the cache. So the first cache that we get back is so cache is this is a oh my god, see, look, I'm writing this. Look, I have the space here. I'm putting a space here. It's funny. Or something. So what is this typed as? Used before being assigned. Can I just like undefined or something? What's Alt Shift F? What is that? I don't know what that does. Oh, I just write format. I just like type in format. It's Control Shift I for me. Okay. How do I use cache? Like, I want this to be like undefined. Ah, okay, that's a good. Okay, great. So we basically only waiting for. We are waiting for Pong. Yeah, should I not do that? Yeah, this is better. Pong. So we only want Pong. Undefined is yuck? No. What are you talking about? What are you talking about? It's fine. You would, yeah, okay, you deny my PR. Good thing I'm not employed. Good thing I'm not interested in being employed. So if it's Pong, cache equals cache. Undefined, null, whatever, nullable. Okay. I'm just gonna assign this data cache. Okay. So if cache. Why are you using a heart rate monitor? If cache existing. Ends. So we have multiple workers. Should kill this one. How do you get a reference to a worker? Wait, no. There is no references to a worker. Ah, wait. Does it matter? No, it doesn't matter at all. I think we can only count how many workers we get. Of course, they kill themselves. Well, what I can do is I can reinitialize, like. Okay, this shouldn't be the case. This shouldn't be the case because I'm taking a web lock. They should all have the same caches. Vietnamic Development 2. Hello? Good to see you. First time chat. Yeah, so this shouldn't be this shouldn't ever hit. Because there's like a web lock. What am I building? Webminer. Here. What is a web miner? A miner mines cryptocurrency on the web. Yeah. We have multiple workers. Allow deny. Auto mod. Held message for a reason. What the hell? Oh no. I'm gonna allow this message. Hillbilly country. What do you mean? This is my own country. Yeah, I don't know, man. I'm clicking allow. So what do I do? A worker should kill itself if it hasn't seen a ping from main. No, okay, this shouldn't matter. It's just like you're always you're always getting the new cache. So if data.cache, if data.cache, cache existing. The amount of pongs that come back are when you return a pong, I think you should return the miner ID. Maybe the miner ID is like pong. Okay, miner ID. This is a random string 1 per. Miner ID. Well, no, it's just going to be randomly generated. It's just going to be like, I'm just going to randomly generate it. Like math.random. Is that not a thing? Okay. So what's the problem? You can write new without the function call. Like I kind of like writing new set. Kind of like writing this. But I'll write that. Add data dots. Owner ID, and you just want to return the amount of like you want to resolve with workers dot length. You want to resolve with a pair. You want the cache. What? Tuples? What do you mean tuples? I love using tuples. Workers. I can't, how do I? Number is no call signatures. How do I get the size of a set? Items? It is size. Oh no, it's not a callable. Okay. Fair enough. As const. What? What are you talking about? Um. Promise, yeah, I know. But it's gonna be so annoying to type. How do you like types in here? Yes. I'm just gonna like do this real quick. Number. That works, right? Oh, great. You know what? Maybe I should use a... Maybe I should use a... You know. Okay, but how do we know when we are finished? True. Website part 2. How do we know? How do we know that this is finished? Maybe we wait like 1 second. How do we know when we're done? When you're done with what? I have to like wait for all the messages to come back, right? But I'm resolving immediately, so I have to like wait here. Wait for like 2 seconds. Is there like an await? Can I like await inside here? Bruh. I know await this promise, but I have to wait for the messages to come back. And then like okay. Okay, because this promise will take 1 second. I have to wait for the promises to come back. I have to wait for the this is on message. This is not going to happen immediately. Oh wait, okay. I have to send this into the ping state. I have to do this. Enter this, right? Into the ping state. Send this. Wait for like 1 second, and then set timeout. What are you talking about? What is there to show me? Oh, work on message. Oh, your data. Wait. You're not understanding me. Like, this doesn't happen immediately. I do. I have to wait. I have to wait for the messages to come back in. I have to wait for the messages to come in. What do you mean it won't resolve until the message is happening? Yes, and it won't resolve. Is that true? No, it's not. Until the message comes back. Are you sure? I don't believe that. Because in here, I'm going to set bc.on message to nothing. Is really this? Oh, okay. Yeah, I have to wait. No, but I have to wait for multiple on messages. No, I'm waiting for like, okay, I'm waiting for as many messages as there are workers. Yeah. I'm waiting for as many messages as there are workers. That makes sense, right? Hopefully that clears things up. Yeah, I'm waiting for like 20 different messages. Uh, why is this? Undefined is not assignable to type. What? What are you talking about? Hold on. Maybe I can just use Maybe I can just use local storage. Maybe I can use local storage to know the workers that are online. So you don't have to wait. What? What is window unload? Oh, okay. Yeah. To deregister the worker once the tab dies. So this is better? This is better? Like, yeah, alright. Okay. Best viewers. Yeah, very funny. Yeah, alright, I'll do the message route. So I have to wait for like 1 second, but I mean, that's fine. That's fine. Yeah. Okay. How do the workers don't know how many workers there are. This is what they this is what they're doing. This is what they're doing. This is like I exist is the Pong. That's a shit way to do it. Okay. I don't believe that. This is the only way to do. What do you mean? Ask somebody in each worker reply back I exist. This is it. This is it. What are you talking about? What? You can use async in here? Oh, that's nice. Yeah, alright. So it's just like a... Do I need to like make a promise or something? This just like returns a promise. Okay, this is like, this might be stupid. This might be stupid. But you know, there are stupider things. Okay. Yeah, I'm not very good at writing. Do you like this code? What idea? Is that not the idea that I'm doing? Okay, well, whoop-de-doo. Fuck, you're unemployed. Okay. Okay, that's not necessary, buddy. Why am I doing it this way? I'm like thinking to myself, like, why am I doing it this way? Okay. Yay, it's an async file. Okay. I'm not allowing that to be chatted. Okay? I'm not allowing that. workers. Cache existing. So, if the cache exists, we want to reuse that cache. We want to reuse that cache. If the job, I can see that. I can see whatever you're trying to send. We want to reuse this cache. Oh, I should use a class. This is where I use a class. I should use a class. Main. What? Where am I supposed to store this stuff? You know? Global state? I can't. It's not in okay. What I want to do is I want to pass this state to something, right? Do I just make a type? I just make a type for that. Fine, I just make a type. Fine, fuck it. Just make a type. But maybe I might want to use a class, you know? Yeah, don't you use classes? All right. I think I'm just gonna make a class. No, I don't want to make a class. Okay, fuck classes. I'll just make a type. Main state is a type. What should I call this? No, okay, you can't do this. Oh, someone doesn't know JavaScript. Oh. I just tried to do that. Oh, you mean here? Whoops. Sorry. Sorry. Whoops. Whoops. Sorry, WHP. True. What should I call this? I don't know, like init. I want to do main state dot find main workers, but you don't want me to make a fucking class. Can you make a class but without a init? No, okay. I don't want to make a class because that makes things annoying. Okay, whatever, new state. W rage bait. Alright. Yeah, I know. Write this functions, yeah. Whoop-de-doo. Alright, new state. So, okay. On the new state. So on job is a thing that takes in the state and progresses the state. So, yeah, static classes. Yeah, so job. So this job will contain the key. Obviously, like this is our job that we have. We just literally we just call st in a loop and it maintains the loop. So on a job, what happens? I don't know. Okay, so if cache is undefined, current job seed hash is not equal to job seed hash. All right, cache existing. This is a string. So yeah, so the current job is job or undefined. Okay, that's better. Current job. So anything with the cache these depend on the current job. Depend on the current job. So, so I'm just gonna like copy this code. Inmaster servers that automatically grant roles. Wow, that's cool. Maybe you should get a job. You have a job. Maybe you should get a fulfilling job. Please, whatever job you have, I need that job. It's like actually unfair. This is like a hex string to a uint8 array. Is there like a nice way to do like do I make this like a function that I can like import or like I don't know, bro. Text encoder, is that a thing? Can you do this? No, but no, but for a uint8 array. No, convert hex to uint8 array. Text encoder. That's funny. Text encoder is afraid of me. No, you're kidding. No, you're kidding. That is a thing that exists. From hex. I mean, like, do I want to depend on this though? This is 2020, like newly available. Yeah, do I want to depend on this? Probably not. Okay, can I use it? Who even has these versions? Is this like bad? Is this bad? What about Samsung Internet? Released 2009. Okay, when was released? I don't want to depend on this. Sorry. This works fine. Maybe I put it in like types or something. I don't know. Util. Yeah, I know it's 150, but it doesn't matter. Um, if C dash equals undefined return, like what? This is never undefined. Does it like expect it to be undefined? No, this always returns an error. Mining those is already fruitless? Nah. You can mine everywhere. Everywhere. Like, it's at this point, because performance is so bad, it's like 5 times slower because performance is so bad. What you want is like volume. Yeah, I know. But like, imagine that. Imagine like, you'd probably get like 10 hashes a second on a phone or something, right? You just want volume. So you want like 10 billion phones. You just want volume. I mean, I don't know. 10, it's probably lower. Might be like 5. Might be like 5. Because on a phone, most of the time they don't use the JIT, so WebAssembly is like interpreted. But that's fine. If you get like 100 phones, that's like normal performance. Why is this undefined? So if cache is undefined. Well, okay, why am I saying it's not equal undefined? It's if cache. If cache. Yeah, if cache. Reuse cache. K, seed hash is the key K, and the cache. It's the existing cache. Does that work? You don't want to reuse the cache. You want to use you want to reuse the memory region. Cache memory, cache exports. Um. Yeah, you want to reuse the exports. Yeah, you want to reuse the data set. Uh, how about I do it like this? Cache, RX cache is like. Should I deprecate this? I'm not deprecate. I'm gonna just fucking delete it. Um. Okay, so you reinitialize with a new cache. Buffer, right, and then we'll have assembly dot memory. If you are WebAssembly memory. Oh, okay. Um, hmm. No, you can't have that. Hmm. Um, what's in a RX cache? Okay, so I just want to like I can just like create this manually. I can create it manually. So I just need to expose the ability to get the thunk create module. VM, the data set. We're going to get the pages of the data set, so okay. We don't actually care about that. We only care about it's a uint8 array. This is about some pages. It's always going to be shared. So it doesn't matter. Yeah. So if we have the cache, reuse the cache. If we don't, reuse the cache. So st.cache is WebAssembly memory. So it's just no, it's not st cache. If we don't have a cache, we want to create a new one. So new WebAssembly.memory. No, not memory. How do I usually call it? Yeah, so it's just like initial SSM. So initial. Shared is true. Okay. Try to reuse the cache if you can. And you want to also reuse the VM if you can as well. So you need, the VM is not a thing, it's the data set. Yeah, it's a data set. All right. Yeah, I know. A dot yeah, you also, so you need a cache, and then you also need the data sets. So we want to model RXCache. This is memory from this thing, right? And then the thunk, the thunk needs to be recreated every time. In fact, why don't we just like put one here? Okay. Workers return st. Description. Worker description. Right. Yep. What we're missing is the cache itself. So the cache is an RX cache. So when we create the cache, so new RX cache. So we need to basically create all of this stuff. So create module should take in memory. This should be moved. If you need to create module, you need to do this. Okay. So when we use create module, it'll just return the exports, right? We'll start a set module. Also needs to create the thunk, which you need to use initialize for. Yeah, okay, so, and then it's just like, so basically, you want to create a module which takes in the memory that you just gained. Okay. If new WebAssembly memory shared is true, yeah, if you don't have the memory, just create it. Okay, so create internal module. This will return a dataset module. This is exports. And then what you want to do is you want to initialize, right? This is initialize given the key. Initialize given the key. Howdy, it's good to see you. See you first time chat. Project I'm working on is webminer, RXJS. It's like the first implementation of RandomX to run on just web standards alone. I'm just working on the proof of concept webminer. So this takes in the key. So this is something you skip. Memory exports. Yeah. Okay, great. So this is separate. Explain more. Okay. This is like, you know, cryptocurrency, like mining, cryptocurrency mining. This is just an implementation of like cryptocurrency mining in JavaScript, right? just an implementation of that in JavaScript. Like I've like made a presentation about it. So like if you're interested about what it is, like what it is in deep,
Hey.
like I just sent that in there. But this is why it's important is because like it's the first implementation of like randomx. Randomx is a hash function. It's for Monero. Why would you mind using JavaScript? It sounds inefficient. It is very inefficient. So so when randomx came to be, right, when Monero did their hard fork and changed to randomx, all previous web miners like have been killed like completely. But the thing is like this is like the library to like enable web mining. Even if it's like slow as shit, at least like you can. At least you can web mine. So if you look at the benchmarks, it's only 5 times slower. 5 times. That's pretty good. That's not that. That's like pretty good. So it's not. It's not. I'd say it's like about of order. It's like 1 order of magnitude slower, which isn't that bad, honestly. Like, I mean, the original reason why I made it is because it just seemed like a good engineering project. But yeah, I mean, like if you look at the benchmarks here, this is like naive threading. It's like 250 hashes a second, so that's like 5 times slower. Well, it's more like 4 times slower than my machine. But I'm working on like a better proof of concept web miner. This is like a shitty naive version that just runs in a loop. But this thing will actually do like stratum and everything. But I'm working on that. Working on that at the moment. Exports. So main state. You can't get the cache without making it. This is initial memory. This is the initial state memory. Initial state exports. You don't need the handle. You just need this. Huh. This is the VM handle. Assembly dot module. Handle. VM handle, cache handle, VM handle. VM handle. Okay, make a new cache and then start current job. Okay, one cache handle. And then so exports is something you don't want. Yeah, you just want these two. All right. This is data set. All right. So this is the WebAssembly module. This is the you don't want to initialize. No. This is the VM handle. Yes, you want the VM handle. VM handle does not exist. Oh, okay. All right. VM handle. RX cache handle. Perfect. Current job handle. Yeah. Where's the cache handle? The cache handle is the memory thunk in the VM. How do you create the thunk? Hmm. Given the key, given the memory, given the data, given the exports. Maybe the exports is not that important. Yeah, I'm gonna move the exports. So create module is separate. Yeah, okay. So exports is separate. So this is its own thing. Because the exports can already exist. Okay, so we'll just make a export function. Create exports. So this is given a create instance. This takes in a dataset module. Takes in memory. Assembly module and returns dataset. Set module. Internal initialize takes in the VM handle. The VM's the VM's constant. All right, so I just take this entire thing. Staying at current job handle. Yeah. So VM handle, yes, this is separate. This is separate. So you want this, right? Main state's cache handle. I mean, this is always going to be created. Yeah. This is always going to exist on creation. So what's in the thunk? A thunk is, so it just contains the memory. Thunk. Yeah. Okay. Cache. Memory. Cache. Cache thunk. Cache thunk exports. So this is a assembly. Oh no, this is a data set module. I mean, that's not very useful. Yeah, this is okay. This is a data set module. Dataset module. This is the thunk is a WebAssembly module as well. Cache thunk exports. The VM handle was also a module. And then the cache handle. Handle is cache thunk VM handle. Yeah. So this is what gets returned. Okay, so cache handle is, yeah, so this is cache memory. Cache handle is separate. Asset wasn't pages shared. Yeah, that's created. So the VM handle is, so the dataset handle is the same thing. So we're going to take this from here. That was dataset TS. That's what we want. All right, this is exports. So I'm going to do it like this. Cache thunk exports. Cache thunk is something that's not always going to exist. Cache thunk. Depends on the key K. Yeah. Yeah. This is the exports for VM thunk, cache memory, cache exports. cache memory, cache exports, VM handle. Okay. VM handle. Yeah. Handle is cache memory, thunk, VM handle. Okay. All right. And then you go function. This returns a RX cache handle, which is just three things. It is, so the memory is st cache memory. Thunk is st.vm thunk. VM is st.vm yeah, handle. Okay. This can't be null ever. Yeah. Okay. And thunk. So if not initialized yet. Yeah, that's how you got the handle. Okay, so if st cache memory or st dot current job, so this is initialized with the handle. So depends on the key from current job. So VM thunk. Yeah. So if current job seed hash, go to the job seed hash. Yep. So st cache memory. Try to reuse the cache. So okay, we have a new cache. Well, obviously, wait. This is always true, so we don't need to do this actually. All right, and then we want to initialize, right? So we want internal initialize. The key cache is seed hash. We want memory, st dot memory, st dot cache exports. Perfect. So like dot trace, what's that? What's that do? No. What you want is time end. Okay. So initialize the cache. So that's basically what we want, right? So internal initialize. So we'll run the key. This will return a new RX cache. This takes in the VM handle. That's probably fine. So then we don't need this then. Okay. Current job. This is this, right? Job. This job. No. This is a job. RX cache. This is an RX cache itself. Yeah. Much better. So we don't need the VM handle because this is just like handled anyway. So this is st.currentJob, job.seedhash. RX cache. Okay, better. Yeah, so current job is initialized now. So obviously, we're gonna initialize it with the job itself and the cache. Great. Okay, so we have a current job. X2 bin is this. To target is its own thing as well. This can't ever return undefined. Okay, and then we distribute the nonce space to workers. All right. Yeah. So we send them all a new job. BMM54. Hello. Good to see a new chatter. I'm currently implementing webminer, RXJS. Actually, I'll put this in the chat, like, again. Oh yeah, like the YouTube video in there is like the explanation of it. Okay, so job. So the request to mine, the job ID, the blob target. Yeah. Okay, so message mine. Job ID is st.currentJob, no, current job ID. I just do this. I just like merge. I want to merge job, but I don't want to send. Nah. Yeah, job. Dude, do you have a minute? Yeah, I do. Yeah. Anything you need to ask me? No JavaScript HTML? Yeah, I do. Yeah. I mean, I'm writing it right now. A bug in Squarespace? Oh, I don't know if I can help with that, but like, you just like explain it. Nonce 0. Yeah, temporary. Okay, they're both set to 0. Temporary. Okay, JIT feature. The mobile menu opens and the hamburger button doesn't show. Yeah, I don't think I'd be much help with that. But I hope you find a solution. It's cache. Cache is not like a thing, right? If the job changes, it needs a new. It needs init. New work is created from nothing. New work is created from nothing. Existing workers get new cache. Yeah, so a new job is like new thunk every time. So this is like thunk. Let's get some new thunk. init bash. So bash. So it's allocated once, yeah. So we want to send a new cache. So the implementation of this doesn't use a broadcast channel. How do I know what worker is what? What worker gets what non-space? Message init new cache. Thunk is rxcache.thunk. Yeah. Really? Is that not? Oh. Of course, yeah. All right. And then bc dot post message. Yeah. Derived from K. Thunk is the superscalar hash. Right. Superscalar hash instance. That's the thunk. Okay. BC post message. And then we can only send one message to mine. So we are not using message goes out to all. So how do we know what worker will get what nonce space? I guess like if you get We only know, okay, what if a worker, okay, a worker will never die. We only know how many workers there are, not, hmm. My issue how do I distribute the nonce space to each of the workers when I send a single message, it goes out to every single worker. Every single worker, so... I don't know. Let me think. Well, I'm gonna have a break. I'm gonna go, like, take a shit, drink some water. Bathroom break. Hello. I'm back. So, distributing the nonce space with certain miners. How would I? Because I need to be aware of what miners exist. So ping does nothing. I'd assume that they ping every now and then. It might be better, or instead of this, right? Instead of this just repeatedly pings over and over and over again. Would that be better? Yeah. They're basically just repeatedly going pong, pong, pong every, what, 500 milliseconds or something? 500? I have a snippet of the code from CoinHive. And this is the CoinHive code. It's like taken from Web Archive. Current job. Message data ping. Last ping received. Does that matter? No, it doesn't matter that much. Get num threads. New CoinHive job thread. Is that like a separate? Is that like a thing? Okay, this creates a new worker. Okay, it's new workers per, and then they just send something to the thread. Yeah. What's better is this pong just gets sent every now and then. So it'll just be hashes per second, number, hashes total, number. Current job ID, string. These are just like stats. Stats. Job ID. Can be null. Hashes per second is number, hashes total. Miner ID is that like own thing. They just send caches repeatedly. They just send pongs repeatedly. Yeah, it sends pongs repeatedly. If you get a new job and you're not in the list, you just die immediately. Yeah. So the job of the worker is to send pongs. So Pongs every what? Every this is verify ID. What is verify callback? What? Verify? Unverified. Oh, it's just sending the WebSocket, right? Yeah, sending the WebSocket. Okay. Yeah, I mean, should we send stats every 500 milliseconds? Yeah. So we don't need this then. Okay, so this is workers take in workers is just a hash, it's just a map, right? Just a map from string to like Pong. Right? String to Pong. Uh I mean that seems fine. Worker Pong or nothing. These are just references to the shared cache, so this takes up nothing. Main watch workers. Workers is a map. Make this, right? What it will do is it'll just go BC on message. If data is Pong. Workers. Sets. Miner ID. Data. Okay. On message. What does it do? Okay. Watch main workers. Okay, so obviously you want workers Pong. Type. Probably better to just like not. New that workers, right? This is just going to run in the background. Run in the background. Okay, and set timeout. We want to wait like 100 seconds or something. Where's bun.sleep or something? What does this do? It's equivalent to this. Okay. Perfect. New promise set timeout resolve 100 milliseconds. Sleep for 1 second. Get workers. New state is something that we don't care about. New state is, well, we're going to construct a new state. Huh. This is interesting because I want this to listen in the background, but ignore any workers that don't have the current cache memory. How about I run this for like 100 seconds? BC on message. How about MS number? If we have a timeout millisecond, if we need a timeout, if we need a timeout, we just sleep. And then vc.on message equals null. Yeah, that's better. On 100 ms. It's in every 500 milliseconds or so, and then when we construct this. This is to be ignored. Yeah, so okay. Initial workers. Obviously, okay, we want to iterate through all the workers. I forget how to do this though. Iter or something? It's just like workers, right? String. Yeah, okay. Value. So in the initial workers, we want to how about this? st main stack. If empty yeah, if st is empty, so if st we want to sleep after 100. Yeah, okay. Well, that was hard coded already. Sleep get workers, right? If st worker die, worker will, oh, sorry, can't see that. Worker will already die if it doesn't exist in the workers list on mine. If st st.cache memory does not equal to data.cache, Yeah, bc dot post message. To worker. Miner ID. Else, if if not st and data.cache this returns a promise. Has to return something, right? Yeah. So, okay, this is like got multiple overloads. This overload, this is true. This is promise void. This is true. This is this. No, if this has got a main state, it's a promise void. If it's this, it's this. Memory or null. Okay, if cache. Right. Message null, return cache. Fuck is memory? What? Oh, yeah. Okay, so if not cache, well, we didn't find one. We didn't find one. So we need to allocate it, like last time. Okay, and then return it. If not killed, we set it. Yeah, I think this is right. Yeah, so in watch main workers, right, we want to pass nothing, which means we will get a WebAssembly memory. And then when we call new state, we want to, initial workers. Memory. When we get the new state from hash in workers, then we iterate through the workers. What we're basically, oh, well, I mean, we're extracting out the cache, but we already did extract out the cache. So then it's just this. Cache. Workers is workers, cache, memory. Okay, main, new state. Okay, and then main void. Okay, I mean, that's just better. So we found a new job. So yeah, we found a new job. And they are, yeah. Okay. So workers start paused. They get a new job. On this job, initialize a new cache. Set the new current job. Init cache. All right, then it's mine. Okay, and then with all the worker IDs, this is put in a map, right? So worker message mine. So there's not nonce ends and stuff. It's allocation, work allocation. This is a map. It's a record from string to this, which is really a nonce number, nonce nonce end. Is it like record types? Hmm. Give me a sec. Record types. No, record type TypeScript. I want a better type than this. Intrinsic? Hmm. Maybe this is useful. Okay, this is not useful. Okay, this is probably fine. That's the work allocation. Oh. Okay, so worker message mine. Work allocation. Work allocation is this thing. Nonce space. All right. We want to loop through of st.orders miner ID. It's just the miner ID. Okay, we want to avoid a race condition. Keys. Keys makes a copy. I don't want a freaking iterator. To array. Yeah, miner ID. Okay, and in this miner ID, what am I doing? The non-space stuff. Yeah, so it's just this thing. So distribute non-space to workers. Yeah. Call it miners, workers, same thing. Miner ID of worker, that's just minus. Okay. So, let's. So the job for this one, the work allocation, miner ID, they each get a miner ID itself. I mean, obviously. They get nonce, which is nonce. And then nonce end is equal to nonce plus nonce space. So just like a clamp. All right. And then nonce plus nonce space. All right, and then this is the job to be posted. So it's just work allocation. bc.post message. Not to message, to worker. To workers, like to the workers. Yeah. I think that's good. I don't need to ask for hash rate because they're just always going to be like running. I think that's it. Yeah. Then do more stuff. Okay. So workers need to be created. Yeah. So watch main workers. Watch main workers will run when it'll create. I think it'll. What we'll do is it'll watch the amount of workers in here and just create new ones to fill it up. Based on the amount of things, like based on the amount of workers that need to be done. Can you go look at the coin hive, right? What do they do? Can you do like job thread? Who creates the job thread? Okay, start now. Set num threads. Yeah, target num. Okay, so how do we get the target? Okay, so it's just like get the stats, get the thread stats. How would we do? We need to do like a, okay, we need a config, and then we'll have target res. The config will just be hard coded. Just hard coded for now. Watch main workers should also create workers, if need be. So if st, watch create workers. Takes an st. This will watch workers. This will just like takes in a config. So if config.target thread, so if no config target threads is navigator dot concurrency for So config target threads, how to work is, I think, yeah, we just use for, and then so when the target threads are down, it'll try and meet that, right? Num threads num. They'll just try and kill the thread. Hold on. What is this code? What is this? I equals 0, loop on something not dependent on I plus plus. Oh, okay. No, okay. It does threads push. Thought it was just like stupid. Hmm. Yeah, so it's just like it's just as simple as creating more threads. So it should slowly ramp up, right? Slowly ramp up beyond the threads at a time. Like, you should repeatedly loop. So while, if, all right, you want to slowly ramp up. So you want to get the diff. So if target threads don't have support for lowering the threads. It'll die off on its own. Oh, should we do lower the threads by just removing from the list. By just removing from the worker list. No, continue. So, oh yeah, sleep. Eat. Should like a promise like this, right? We'll make a we'll make this. That's not how you spell any of that. MS is number. And return. So sleep. Yeah. Really? This goes to bun? Don't go to bun. Yeah, take from here. No, 200. So the diff. So this is true, right? You want size, right? I mean, do we need that? I mean, we just need to add these things and just wait for all of them to be created. Yeah. All right. So for let I equals 0, I is less than diff, I plus plus, main create worker. This is just waiting, so. How do you curry something? I guess you just do it like that. Promise unknown? What is void? It's pretty naive. Okay. When workers come about, main create worker. We need to create a new worker, obviously. All right. Do workers die when a tab is closed? Hmm. seems like a problem. Oh, okay. Shared worker does exist. Interesting. Hmm. What doesn't Chrome support? Only this? Hmm. All right. Okay, as I understand it now, I didn't understand it previously in the past. A shared worker, okay, so a workers, so worker, this worker, they're owned by a tab, and when the tab closes, they die. Which is, I thought it was different. I thought that when, these workers they float around until all the tabs close. No, that's a shared worker. But the thing is that you need to have shared workers implemented. So shared workers are implemented everywhere, except for Chromium on one thing. So they're actually implemented everywhere. Can I use... Okay, click, please. Yeah, I mean, this is like supported everywhere. Okay, shared workers supported everywhere. Okay, um, this implementation, like using broadcast channel, this was built upon the fact that when the tab closes, workers don't die. So, yeah, when the tab closes, the workers don't die until all the tabs close. But that's not true of workers, right? So when the tab closes, all the workers die. And then this like kills everything. So broadcast channel works across tabs. They work across tabs, but it's not really useful because like I can like hold all the workers, but when the tab closes, like they're all dead. So it's not like I can switch from main to a different tab. For example, this thing, right? This weblock. This is supposed to be like every single tab that gets opened attempts to become main. Every single tab that gets opened attempts to become main. And like when they become main, right? Let's say like you close a tab, you open a new one, all those workers die, that new tab becomes main, but like you're gonna have to create the workers anyway. So doing it this way is just stupid because if you're only using worker, you can't reuse the workers. Yeah, you can't reuse them, which is a problem. Unless you want to use shared workers. Unless you want to use shared workers. So in shared workers, when the tabs are all alive, and you like close a couple tabs, but there's like at least one, um, the workers don't die because they're held on by something. So then another tab can assume main and then continue it on. But I mean, is that something that we want? Like, is the hassle worth it? Is what I'm saying. I don't know. I don't know if the hassle's worth it. I might need to ask around. I might ask around to find out if the hassle's worth it. But you know, I think it was a good stream. So this is attempt of allocation. Just continue on from here. All right. I think that was an alright stream. Alrighty. Goodbye.